So good day everyone. For today's topic, we'll be talking about geothermal power plant. Okay, before we dive into this topic, let us first know the objectives on our discussion. So the first would be to introduce the fundamental principles of geothermal energy. The second objective would be to explore the key components and the types of geothermal power plants. The third one and the last would be to highlight the environmental advantages and challenges of the geothermal energy. So now for the introduction to geothermal energy often referred to as Earth's heat is a remarkable and sustainable source of renewable energy. It harnesses the heat emanating from within the earth to generate electricity and provide direct heating for various applications. So kani siyang geothermal energy, it has been exploited as source of heat and electricity power for millennia. Nagadugay na gid siya gamit. So magkot ay energy from the earth's heat which himuon na para ma-turn into renewable energy and magamit siya for daily use sa mga tao. So now for the sustainability and environmental benefits, we have renewable and exhaustible. So geothermal energy derives its power from the Earth's internal heat, a resource that is virtually inexhaustible on human timescales. Unlike fossil fuels, geothermal energy will not run out. So as what was mentioned, renewable gini siya nga kind of energy because dili ni siya mahurot or it will not run out, so it will like continue 24/7. This kind of energy is good siya and very useful. And for the second one, the low carbon footprint. So geothermal power plants emit minimal greenhouse gases during electricity generation, making them a vital component in the fight against climate change. This low carbon footprint contributes significantly to reducing our environmental impact. Isa sa nakanindot sa geothermal energy is that low carbon footprint siya. So, mo siya vital component nga maka-fight siya against climate change, di siya maka-contribute nga mas ma-damage siya nga to ang environment. Like minimal lang kaayo ang mga greenhouse gases nga iyahang ipagawas during electricity generation. Mao na nga nindot siya as a source of energy. So the third one would be continuous and reliable. Unlike some other renewable sources like wind and solar, geothermal energy is consistent and available 24/7, providing a reliable source of power that can be tapped into year round. So nag-mention naman ko ganina nga kani yung geothermal energy 24/7 yun siya available, like makakuha kita ani whenever we want as long as we have the right equipment to convert this energy into a useful one. Okay, so the next one and the last one would be reduced air pollutions. So geothermal power plants release a very few air pollutants compared to fossil fuel based power plants, improving air quality and surrounding areas. So, geothermal nga mga power plants daw is mag-release sila mga gamay lang yun kayo, like minimal air pollutants compared sa mga fossil fuels nga mga kind of energy. So the basics of geothermal power plant. So geothermal power plants operate on a simple yet profound principle. Harnessing the Earth's natural heat to generate electricity, this process is made possible by transfer of thermal energy from the Earth's interior to the surface. So the energy comes from the heat of the Earth's interior. So gikan yun siya sa innermost part sa Earth. So kani in the process of geothermal energy, ang reserve of steams on hot water will with temperatures higher than above 225 degree Fahrenheit can generate electricity, while lower temperature geothermal fluids are often used directly for heating and other applications. So there are like specific yun nga mga temperature para sa different kind of use and applications aning geothermal energy. Now for the working principles. First would be the heat source. Deep within the Earth's crust and mantle, there are vast reservoirs of molten rock and water, often referred to as magma chambers or geothermal reservoirs. These reservoirs contain an immense amount of thermal energy, a remnant of the Earth's formation and radioactive decay of elements. So naad daw like mga dagkong reservoir ana of molten rocks and water. So ang gitawag siya magma chambers. So kaya ba man to sa reservoir mo na siya like moist tudlanan nga para adto ma-store to mga like heat gyud like to mga molten rocks katong mga ma-turn into energy adto siya na stored sa reservoir. So the next one would be heat transfer. The intense heat from this reservoir causes the surrounding rocks to heat up. Over time, this heat is conducted through the Earth's layers, gradually making its way towards the surface. So kadugayan aning intense heat nga gikan adtong murag sudanan katong reservoir because na siya nga ang mga surrounding rocks moinit pud siya apil. So kadugayan ana ang heat magkatag-katag na siya. So kadugayan ana ang heat moabot na siya mag-make way na siya towards the surface. So the third one would be the surface expression. In regions with active geological processes such as tectonic plate boundaries or volcanic activity, the Earth's internal heat can manifest itself as hot springs, geysers, or volcanic vents. These are visible indicators of the vast underground heat reservoir. So kana daw like na ay mga region nga nay active geological processes, nga nay mga tectonic plate or mga volcano, and that way the internal heat can manifest itself like adto sila magpagawas sa more like sa mga hot springs, sa mga geysers or mga volcanic vents. So the next one would be harnessing the heat. To harness this heat for electricity generation, geothermal power plants drill wells deep into the Earth's crust, tapping into the high-temperature reservoir. The heat is then extracted through these wells in the form of hot water or steam. Drill sila mga wells nga mga lawom gyud into the Earth's crust nga makaabot siya adtong mga reservoir bitaw kung asa tong mga molten rocks katong asa tong mga pwede ma-turn into renewable energy. Then the heat is then ma-extract na siya through these wells and sa form nga hot water or steam. So ang next is the power generation. This will be the last part of the working principles. So the power generation, the extracted hot water or steam is directed to the surface power plant where it is used to turn turbines connected to generators. As the turbine spins, electricity is generated which can be transmitted to the grid for distribution. So adto na-extract na siya, extracted hot water or steam. So directed to the surface power plant where adto they used to katong mga na-extract mo to siya gamiton to turn the turbines pala tuyokon siya nga naka-connect po siya sa generators. So as the motuyok tong turbines ang maka-generate siya og electricity which can be submitted or transmitted to the grid and ana nga part ma-distribute na siya kung asa siya paingon tong mga The next would be the Earth's geothermal reservoir. So the first one would be connective zones. These are the areas where the Earth's mantle is in constant motion due to convection currents. The movement of the molten rock generates intense heat, creating convective heat reservoir that can be tapped into by geothermal power plants. So mo ni siya nga part sa Earth which is mantle na in constant motion, so galihok jud siya due to convection currents. Kay kani mga siya na part is that nag-generate siya og intense heat nga maka-create sa convection heat reservoir that can be tapped into the geothermal power plants. The next one would be the hot dry rock or HDR. In some regions, there may not be naturally occurring hot water or steam reservoir accessible through drilling. In such case, geothermal power plants can create HDR reservoir by injecting water into hot, impermeable rock formations and then extracting the heated water. So, kind siya more on like man-made ni siya nga kind of heat. Kay, as what has mentioned, mag-inject sila water into sa mga init nga rock. So, and then mag-extract nila tong na-heat na nga water. So the last one and the third one would be the hydrothermal systems. These are natural geothermal reservoir where water circulates through fractured rocks, becoming heated by the Earth's heat. Hydrothermal systems are commonly associated with geysers, hot springs, and volcanic activity. Kanito sila tong mga natural reservoir bitaw, like not man-made, where ang mga water mag-circulate lang yun siya sa mga fractured na rocks kanang nailiki nga pwede nila kalusutan sa mga tubig. So ana, init man na siya nga mga parts sa rocks. So muinit sa tong tubig nga misud. So adto sila mag-extract og mga heat nga ma-turn into renewable, mga useful energy. So that would be my topic. So now nakadive in naman ta sa mga sources sa geothermal power plants. Let us now go to the types of geothermal power plants, which will be discussed by Mary Therese Cartagenas.
Thank you, Ms. Ayaay, for providing an insightful overview of the fundamentals of geothermal energy and its environmental benefits. Now, let's dive deeper into the key advantages of geothermal energy and explore the various types of these remarkable energy facilities. As we continue our exploration of geothermal energy, it is important to understand the compelling advantages that make it a standout in the renewable energy sector. A key advantage of geothermal energy is its reliability and consistency. Unlike some other renewable sources such as wind and solar, which are intermittent and weather dependent, geothermal energy provides a continuous and steady source of power. It is available 24/7 year-round, making it an excellent complement to other renewable energy sources and a reliable baseload power option. This stability is crucial for ensuring a consistent energy supply, reducing the speed for backup power sources, and meeting the demands of a modern energy grid. Moving forward, we will unravel the fascinating world of geothermal power plant types including dry steam, flash steam, and binary cycle, each with its own unique operating principles and applications. The first type of geothermal power plant is the dry steam power plant. So this is the simplest design. Its working principle is that it draws the steam directly through a turbine, as shown in the left side of our presentation here. From the projection well to the turbine, the steam will go towards the turbine, causing it to rotate. Then it will then go back to the injector well. It then goes to, from the turbine, it will then go to the condenser where the steam becomes water and go back to the, go down to the injector well. In dry steam power plant, high temperature steam directly from the geothermal reservoir is used to rotate a turbine. The high pressure steam is channeled through a nozzle, which expands it and increases its velocity, causing them to spin, causing the turbine blades to spin. The turbine is also connected to a generator, which then converts the mechanical energy into electricity. So here is another figure showing the dry steam power plant. So with its parts, production well, turbine blades inside of it, then the steam will go back to the injection well and become water. Then turbine is connected to the generator through a shaft. Then the load here, which symbolizes the electricity conversion of mechanical to electrical energy. Second type is the flash steam power plant. It utilizes high pressure and high temperature water from the geothermal reservoir. And when the high pressure water is released into the lower pressure environment, such as flash tank, it flashes into steam due to pressure drop. The resulting steam is then used to turn a turbine similar to dry steam power plant. The steam is then condensed back into water after passing through the turbine and the cycle repeats. So it can be seen the cycle or the working principle of this power plant type is can be seen at the left side of our presentation. So production well to the flash tank, then to the turbine. Turbine will rotate as well as the generator. Then the mechanical energy from generate produced here will be converted into electrical energy for power generation. The steam the steam in the that passes through the turbine will go down to the injector well. As you can see the steam here, this is extremely hot water inside the flash tank, rapidly depressurized or flashed into steam. The third type is binary cycle. It uses a secondary working fluid with a lower boiling point than water. Example, organic Rankine fluid, lower boiling point than water. The geothermal fluid, typically at lower temperatures, is used to heat the secondary fluid in a heat exchanger. So for this type, it uses a heat exchanger. This secondary fluid vaporizes at a lower temperature, driving a turbine as it expands. Then after passing through the turbine, the secondary fluid is condensed back into a liquid and returned to the heat exchanger for reheating. The geothermal fluid remains separate and does not directly contact the turbine. So this is the diagram of three types of geothermal power plant. So this is dry steam. The first figure, the dry steam will just go directly to the turbine, causing it to rotate. While flash steam, it uses steam separator or flash tank. Before going to the turbine, it flashes the steam towards the turbine. While in the binary cycle, it uses heat exchanger for lower temperature nga geothermal fluid. These three main types of geothermal power plants provide flexibility in harnessing geothermal energy, allowing for adaptation to varying resource conditions. So for dry and flash steam, they work with high temperature resources, while again binary cycle, it is suitable for lower temperature resources. Each type has its advantages and is chosen based on the specific geothermal resource characteristics. So, but first, let's take a global perspective and examine the remarkable growth in geothermal energy production worldwide. It is inspiring to see how geothermal power is making a substantial impact on the global energy landscape. So this figure here in this slide shows the linear graph of the global geothermal energy production from 2000 to 2022. Specifically, in the Philippines, Oceania as a region, Costa Rica, and Russia. For Russia, its geothermal energy production has remained relatively modest through the years, and the data indicates here that Russia has not been a significant contributor to global geothermal energy production. Russia presenting the line that represents the in violet color or purple. The bottom, this is Russia. Then This country might have untapped geothermal potential, but other energy sources have likely taken precedence. Second is Costa Rica. It has demonstrated a consistent commitment to geothermal energy over the years, and the data may show an upward trend in geothermal energy production, reflecting the country's emphasis on renewable energy sources. The country's investment in this energy source aligns with its environmental goals and efforts to reduce carbon emissions. And third, for Costa Rica, it is above the Russia line. So next is Oceania as a region, representing the green line. As a region encompasses several island nations, including New Zealand and smaller Pacific islands. Geothermal energy production in Oceania has likely been influenced by New Zealand's active utilization of geothermal resources. The data may show an overall increase in geothermal energy production in the region, driven by both New Zealand and other Pacific island nations exploring geothermal energy as a sustainable energy source. Lastly, Philippines. It has been also a consistent in using the geothermal energy. It has also been a consistent leader in Southeast Asia for geothermal energy production. The data may indicate steady growth in geothermal energy output over the years, and the country's focus on geothermal energy aligns with its efforts to diversify its energy mix and reduce dependence on fossil fuels. Overall, the interpretation of this data highlights the varying levels of commitment and success of these countries and regions in harnessing geothermal energy. While some, like Costa Rica and Philippines, have shown dedication to expanding their geothermal capacity, others, like Russia, may have not yet fully tapped into their geothermal potential. Additionally, Oceania, driven by countries like New Zealand, has likely contributed to the growth of geothermal energy production in the region. These trends underscore the global transition toward cleaner and more sustainable energy sources and the role of geothermal energy in achieving these objectives. So, this map here offers, in the slide, this map offers a geographic perspective highlighting the top 10 countries driving this growth. Among them, the United States, Indonesia, and the Philippines have stood out. So dark red here are Philippines, Indonesia, and United States. They have stood out as leaders, collectively generating approximately about 50.13% of the global geothermal energy output. These three countries have made substantial investments in harnessing the Earth's natural heat reservoir, affirming their commitment to renewable and sustainable energy. So this is energy production map in 2022. So this figure shows the pie graph illustrating the substantial surge in global geothermal energy production with an aggregate capacity of 16,127 megawatts. The graph emphasizes the prominence of the top 10 geothermal energy producing nations, which collectively accounted for about 93.2% of the global geothermal energy production, while the remainder, categorized as others, contributed significantly as well. So interpretation of the geothermal energy production data in 2022, the significance of this statistics lies in the growing recognition of geothermal energy as a vital component of the global energy mix. The top 10 countries or nations are playing a pivotal role in expanding the reach of this reliable and low-carbon energy source, contributing to a greener and more sustainable future for us all. This data underscores the increasing importance of geothermal energy in achieving our renewable energy goals and mitigating climate change. And as we move forward, it is crucial to continue supporting and investing in geothermal projects to further harness the Earth's heat for a cleaner and more sustainable energy future. Finally, we will then delve into the intricate machinery and systems that make up a geothermal power plant. So, shown the figure, these components work harmoniously to convert the Earth's natural heat into clean and reliable electricity. Geothermal power plants consist of several essential components that work together to harness the Earth's heat and convert it into electricity. Each of these components plays a crucial role in the efficient operation of a geothermal power plant, enabling the conversion of geothermal energy into electricity. The choice of components and their configuration may vary depending on the specific type of geothermal power plant, like the dry, flash, and binary cycle, and also the characteristics of the geothermal resource. So this is a diagram showing the how geothermal power plant works from the reservoir by heat conduction to from magma reservoir by heat conduction to the geothermal reservoir, then to the production well, the steam from the production well going to the turbine with or without steam separator depending on the type. So separator or flasher, then the steam will condense back to water and then goes to the injection well. So that steam will cause the turbine to rotate, then to the generator as well, producing mechanical energy and then converting it into electrical energy for power generation. So first component or main component is the heat source or reservoir. It is the heart of a geothermal power plant. The heat source, which is a high temperature reservoir located deep underground. So, or others call it as geothermal reservoir. This reservoir contains hot water or steam generated by the Earth's natural heat. Second component is well or wells, or both production and injection. Production wells are drilled to access the geothermal reservoir and extract the hot water or steam, while injection wells are used to re-inject cooled water or condensed steam back into the reservoir to maintain reservoir pressure. Third component is the surface power plant. It houses the equipment required for electricity generation and distribution. It includes components like turbines, generators, and transformers. Fourth component is the power generation equipment such as generator, turbines, etc. Turbines. In turbines, high-pressure geothermal steam is directed through turbines. As the steam expands through the turbine blades, it causes the turbines to spin. While generators, these are connected to the turbines, and it will convert the mechanical energy produced from the spinning turbines into electrical energy. The fifth component is heat exchanger. Heat exchangers transfer heat from the geothermal fluid, water or steam, to a secondary working fluid in binary cycle power plants. This fluid is used to turn a separate turbine. So it is only used for binary cycle power plant. where secondary working fluid here has lower temperature than the water. For example, the Rankine fluid. Sixth component is the condenser or condensers. They are used to convert the used steam back into water, making it ready for injection into the reservoir in flash steam and binary cycle power plants. Seventh are pumps and valves. Pumps are employed to pressurize the geothermal fluid, making it suitable for extraction from the reservoir. Valves, on the other hand, control the flow of geothermal fluids and regulate the process. As we wrap up this section on geothermal power plants, key advantages, types, global production, and their main components, I would like to hand it over to Mr. Umamalin, who will delve into the critical aspects of energy and performance analysis performance analysis, monitoring and optimization, and site selection. These elements are pivotal in ensuring the efficiency and sustainability of geothermal power plants. Mr. Umamalin, please take us through these vital topics. Thank you.
So, good day, everyone. Um, I'm the next reporter about from the geothermal power plant, which is the energy and performance analysis. Energy and performance analysis of a geothermal power plant is an ongoing process which involves collecting and analyzing the data over the time to make informed decision for optimizing the energy production while minimizing the environmental impact and operational cost. So here are some aspects which is the resource assessment, efficiency analysis, fluid and heat analysis, and thermodynamic modeling. So here are the calculations which is the capacity factor. Capacity factor is how uh, measures how the efficiently a geothermal power plant operates. So to calculate it is the capacity factor is equal to actual electricity generated over the maximum potential output times the 100%. The next is the efficiency. It clearly goes how measures effectiveness from a geothermal reservoir in the electricity. So to calculate it is efficiency is equal to useful energy output over the energy input, or the actual energy generated over the heat extracted from the reservoir times the 100%. The next is the availability, which measures the percentage of time that geothermal power plant is an operational and capable of producing electricity. So for the calculations is availability is equal to total operating hours over the total possible hours times the 100%. So for the monitoring optimization is for the monitoring and optimization, there are types which is the performance monitoring, which a geothermal power plant performs is closely monitored through combinations of sensors, data logging, and control system. Key parameters such as temperature, pressure, flow rates, and electricity output are continuously measured. This data allows operators to assess the plant's health and efficiency in real time. So, excuse. So for the optimization strategies, here are the four, four types, which is the reservoir management, regular maintenance, thermal efficiency improvement, and the advanced control system. So for the reservoir management is how to manage a geothermal reservoir, which is to maintain resource sustainability and maximize some energy. Then for the regular maintenance is how a scheduled maintenance and equipment for the inspections, which carries to prevent some downtime and ensure peak performance. Then for the thermal efficiency, which how the engineers work on enhancing heat recovery process, reducing heat losses, and improving heat exchange system. Then lastly, for the advanced control system is how to use some fine-tune the operation of plant on an optimal performance under the very conditions. Then for the environmental considerations, it is to perform some optimization which also takes some environmental factors. Geothermal power plants must adhere from the regulations to minimize some environmental impact such as reinjection of fluids and management of geothermal emissions. For the lifetime assessment is to evaluate a long-term performance of geothermal power plants involves assessing factors like equipment degradation, reservoir depletion, and potential need for plant upgrades or expansions. By continuously monitoring and optimizing the geothermal power plant performance, operators can ensure the efficient and sustainable generation of electricity from the renewable energy source. High capacity factors, efficiency, and availability are essential for making geothermal energy a reliable component of the energy mix while minimizing the environmental footprint. For the site selection is how the various fields, which includes some real estate development, infrastructure projects, and environmental conservations process, which involves the careful evaluation of the analysis to determine the most suited location for a particular purpose. So, for selecting the right site for a geothermal power plant is a critical step on ensuring the efficiency, sustainability, and environmental compatibility. The importance of site selection cannot be um, overstated due to the impact on various aspects of plant operation and long-term success. Site suitability is site suitability for the geothermal power plants is determined by geological criteria such as heat source availability, perma- permeability, hydrogeological condition, geochemical composition, and consideration of tectonic activity. The, uh, the environmental consideration encompass the minimizing ecological impact, maintaining air and water quality, responsible land use planning respecting cultural and social factors, complying with regulations, and mitigating visual impact. For it involves some comprehensive assessment of geological criteria and environmental considerations as well. Choosing this site ensures sustainable and responsible utilization of geothermal resources while mitigating some potential negative impacts on the environment and local communities. It is a critical step for the successful development on the geothermal energy projects. So this is my last slide for my report. So I will I will give from the environmental impact from the next reporter. So
Now let us delve in about the environmental impacts of geothermal power plant. First, let us talk about its environmental benefits. As we know, geothermal power plant is one of the renewable energy, so its advantages includes low greenhouse gas emissions. Unlike other power plants such as coal-fired power plant which involves burning of coals and also diesel power plants that requires burning of diesel fuels which both produces harmful byproducts. In geothermal power plant, the heat source requires no fuel since ang iyang ginagamit is the heat from the earth ug tungod kay wala may burning like the kind of burning mentioned earlier, geothermal power plants produces a very low levels of greenhouse gas emissions, making them one of the cleanest source of energy. Moreover, the majority of emissions come from minor sources like pumps, fans, and other auxiliary equipments. So these emissions of undesirable substances is gamay ra jud kaayo since there are no combustion byproducts. It is not as damaging as those conventional power plants that are derived from fossil fuels. Also, geothermal power plants help mitigate climate change by providing a clean and consistent source of electricity, reducing greenhouse gas emissions compared sa mga fossil fuel-based generation, and decreasing dependency on fossil fuels. Next, reduce air pollution. Geothermal power plants release minimal air pollutants compared to fuel-based power power plants. Kay lagi it is not fuel dependent. So it is not fossil fuel dependent. So emissions of sulfur dioxide, nitrogen oxides, and particulate matter are virtually non-existent since wala man siya require of burning of fossil fuels and coal. Hence, this leads to improved air quality and reduced health risk in nearby communities. Now let's move on to potential environmental concerns of geothermal power plants in terms of land use. Geothermal power plants require land for drilling wells, constructing infrastructure, and power generation. So we all know nga ang development of geothermal power plants requires substantial land use, meaning large area of land is required, which is of course disrupts local ecosystems. Construction activities like drilling wells and building infrastructure may lead to habitat destruction and fragmentation. So this impacts mga local wildlife and plant species which are essential in balancing our ecosystem. Also, geothermal projects may infringe upon lands that are traditionally owned or gipuy-an sa mga indigenous communities. So this would lead to conflicts over land rights, cultural heritage, and concerns about the protection of sacred areas. To address these potential environmental concerns related to land use, nagkinahanglan yun ni siya responsible development and management, proper site selection, environmental impact assessments, mga habitat restoration efforts, and community engagement can help mitigate these issues. Additionally, advancements in geothermal technology, such as enhanced geothermal systems, aim to reduce land use and environmental impacts by utilizing subsurface reservoir more efficiently. Another possible environmental concern is the subsurface effects. Extensive geothermal resource extraction can lead to subsurface effects such as reservoir pressure decline. Unsa man ang reservoir pressure decline? It refers to the gradual reduction in the pressure of the underground reservoir from which geothermal fluids are extracted. So, ang extraction sa mga geothermal fluids gikan sa mga underground reservoir can lead to land subsidence, which where the ground sinks over time. Hence, proper reservoir management is crucial to mitigate this concern. So, kabalo man ta nga there are potential environmental impacts of geothermal power plant, it is also very important to have mitigation measures and regulations. First, it is important to have a responsible land use planning. Careful site selection and land use planning help mitigate habitat disruption and land use conflicts. Regulations often require environmental impact assessments to assess and address these concerns. So responsibly nga pagplano sa land use is very critical or very crucial aspect of a sustainable development. It involves making informed decisions on how land should be used, developed, and conserved. Next is the subsurface monitoring and management. Subsurface monitoring and management refer to the practices and mga techniques used to assess and control activities or conditions beneath the Earth's surface. Subsurface monitoring and management are essential components of geothermal power plant operations to ensure the efficient and sustainable utilization of geothermal resources. It involves continuous monitoring of geothermal reservoir. This includes tracking pressures sa reservoir, iyahang temperature, and fluid chemistry. So if maubos ang pressure, this signals resource depletion, and if there is a change in fluid chemistry, hence it indicates scaling or other issues. So another includes regular inspection and maintenance of injection and production wells, accurate measurement of fluid flow rates in production and reinjection wells, testing, heat extraction monitoring, and many more. So, napoy subsurface imaging like seismic surveys and electromagnetic imaging techniques. Thus, continuous monitoring of geothermal reservoir ensures sustainable resource management, and the injection of fluids back into the reservoir or the reinjection helps maintain reservoir pressure and mitigate subsurface effects. Next, air emission control. Air emissions control in a geothermal power plant focuses on managing and reducing the release of gases and particulate matter into the atmosphere, which can result from various plant activities. So this includes removing harmful gases like hydrogen sulfide through processes like scrubbing, capturing particulate matter using technologies such as electrostatic precipitators or baghouses, and properly handling non-condensable gases like carbon dioxide. So these controls are crucial to minimize air pollution, protect air quality, and comply with environmental regulations, reducing the plant's impact on the surrounding environment and human health. So In air emissions control, regulations mandate strict limits on emissions from geothermal power plants. Advanced emission controls technologies can further reduce environmental impact. Next, we have water management. So, water management in a geothermal power plant involves the responsible use and conservation of water resources, as well as the treatment and disposal of geothermal fluids. So, this includes recycling and reusing geothermal brine, managing produced fluids to prevent environmental contamination, and adhering to regulations on water withdrawal and discharge. So, effective water management is essential to ensure the sustainable use of water resources, prevent environmental harm, and maintain the integrity of the geothermal reservoir. So, responsible water management includes the treatment and disposal of geothermal fluid to prevent contamination. As mentioned earlier, regulations ensure that discharge fluids meet water quality standards. Next, community engagement. So, community engagement involves actively involving local communities, stakeholders, and residents in the planning, development, and operation of the geothermal power plant. So, this includes conducting public hearings, sharing information about the project, addressing community concerns, and providing benefits to the local community, such as job opportunities or infrastructure improvements. So, this is very important no to avoid conflicts about mga tao nga nagpuyo near anang geothermal power plant. So as mentioned earlier, what if sila mo'y tag-iyaan ng ayuta and then ma-infringe ang ilahang area, so there would be a possible problem. So importante nga upon building the project, the geothermal project, it is important to have community engagement. And of course, na mga sharing information about the project ug unsay naa na unsay mahitabo ana nga lugar, or addressing community concerns o unsay mga concerns sa community, like unsaon pag-deal sa mga ah, posible nga mga mahitabo, like unsaon pag-deal sa mga waste, unsay posible nga effects ana nila sa ilang health, and also providing benefits to the local community. So naa may construction, na may project, so pwede mohimo og initiative ang stakeholder to offer job opportunities or infrastructure improvements sa mga community nga nagpalibot sa mao nga project. So this is very important since it fosters transparency, builds trust, of course, kay kung naa kay community engagement, so ang mga tao nga nagpalibot can trust you about the project. So this can further avoid problems or mga issues, and ensures that the project aligns with the community needs and values. So it can help mitigate potential conflicts and negative social impacts. So, project developers often collaborate with local stakeholders to create positive social and economic outcomes. So, importante kayo no nga ang mga project developers, especially in geothermal power plant, mo collaborate, or meaning makig-connect sa mga local stakeholders to create positive social and economic outcomes. Next, we have regulatory oversight. So, regulatory oversight refers to the involvement of governmental agencies and authorities responsible for enforcing laws and regulations related to geothermal power plant operations. So, this is a very common no nga kung magkanta kag usa ka establishment, it is very necessary to meet the standards or to meet the enforcing laws and regulations related to the establishment. So in geothermal power plant, so importante nga na-adjoy involvement, na governmental agencies involvement, and authorities responsible for enforcing laws. Kay what if that power plant, that respective geothermal power plant does not follow the standard or na ay mga wala gis pang sunod nga mga protocols na ay mga laws nga gipang lapas or wala gipang tuman or maybe mga ah, mga kanang actions nga wala ning coincide sa mga laws and regulations nga gimpose sa government agencies. So mao na nga importante kaayo nga naa sila involvement to of course reduce further problems kay what if dili siya kung walay regulatory oversight, meaning dili gyud siya dili siya kung kuan man gani siya ma-impose, so maybe na ay mga further nga problema. So kinsa may maapektuhan ang of course ang mga community pod madamay. So kay this is a very crucial or very big establishment, so importante gyud nga this has met very uh, very carefully the of standard and laws imposed by the government and agencies uh, that ensures the law. So mo na nga kanang naagay mga sa mga power plant naagay mga mo inspect gyud importante bisan sa mga building na yung mga inspection kung na tarong ba og kuan ang mga circuits ning kuan ba siya sa standard sa material, so ingon ana kay importante ang regulatory oversight. So, in summary, geothermal energy offers significant environmental benefits primarily through its low greenhouse gas emissions and reduced air pollution. However, potential environmental concerns like land use and subsurface effects must be addressed through responsible planning. So, importante gyud nga naagay plano, monitoring and adherence to regulations. So importante pod nga na proper monitoring, close monitoring and adherence to regulations, meaning ning follow sa mga regulations, laws nga gi-impose. Mitigation measures and regulatory oversight play a crucial role in ensuring that geothermal energy projects are environmentally sustainable and beneficial to both the environment and local communities. Dili ra ang kanang geothermal energy project nga kanang kanang stakeholder mo'y maka-benefit, kundi maka-benefit pud siya sa environment and local communities. Dili lang ang kumpanya mo'y makakwarta, kundi makahatag pud siya og positive impact sa environment and of course the local communities around it. Now, as future mechanical engineers, importante kay nato nga masabtan nato the very important role of geothermal energy in the renewable energy mix. So, geothermal power is a constant and eco-friendly contributor since it does not depend on fossil fuels, and it and so it offers consistent baseload electricity that complements intermittent sources like wind and solar energy. So as we move towards a world powered by cleaner and more responsible energy sources, geothermal is probably the energy that stands as a beacon of hope. So that would be all for today. Thank you and God bless us all.